Hello, I am Dr. Anubha Gupta from ABES Engineering College, Ghaziabad. I am presenting lecture series on quantum mechanics. This is the part 2 of lecture series. In this lecture, topic to be covered is Compton effect. So first of all, we will understand that what is the Compton effect. When a beam of X-ray scattered by metal target, the scattered radiation contains not only the original radiation but also the modified radiation of a slightly longer wavelength. This phenomena is called Compton effect. Compton effect is basically interaction between the radiation and matter. How the radiation give up some part of energy to the matter means electron, and how the energy changes, we will calculate the energy difference between the incident photon and the scattered photon. This is the experimental setup: X-ray source, collimating slit, target, circular scale, and a detector. X-rays are produced by the X-ray source and passing through the collimating slit, and a fine beam of X-ray is obtained. This fine beam of X-ray is incident on the target. This X-ray beam has a wavelength lambda. After scattering, it has a wavelength lambda dash. So this is called modified radiation of a slightly longer wavelength. Lambda dash wavelength is longer than lambda. And the difference between the wavelength of original radiation and the scattered radiation. Original wavelength is lambda and the scattered wavelength is lambda dash. So the difference between the scattered radiation and the original radiation is called Compton shift, and we will calculate Compton shift here. To solve the Compton shift, first we will understand the energy and momentum of the photon and electron. This blue one shows the X-rays. This X-rays is coming and incident on the target electron. This incident photon has the energy Sc by lambda and momentum h by lambda. It gives some part of its energy to the target electron, and its wavelength become lambda dash and energy Sc by lambda dash and momentum h by lambda dash. Some part of its energy give up to the electron, and electron, by getting the energy from the photon, electron have a momentum p and the energy p square c square plus m naught square c4. This electron is called recoil electron, and it is diffracted at angle phi, and the photon is diffracted at angle theta. So there is a two particle system. In this derivation, there are the two particle. One is the electron and another one is the photon. So by applying the conservation of energy, conservation of energy. Conservation of energy means energy before collision is equal to energy after collision. Energy before collision. In this experiment, in this system, there are the two particles. One is the photon and another one is the electron. So photon has the energy before collision hc by lambda. This is the electron, and at rest, electron has energy m naught c square. After collision, again there are two systems. One is photon, and another one is electron. Photon has energy Sc by lambda dash, and the electron has energy P square C square plus M naught square C4. This is the equation number 1. Now we will apply the conservation of momentum. Conservation of momentum. For conservation of momentum, let us divide this momentum of the photon and electron into the two components along x-axis and y-axis. So this is the h by lambda dash is the momentum of the scattered photon. At the y direction, it will be h by lambda dash sine theta. And along x direction, this component become h by lambda dash cos theta. This is the electron which has the momentum along x-axis p cos phi, and along the y-axis the momentum is p sin phi. So conservation of momentum along x-axis. Momentum before collision and momentum after collision. Momentum before collision is equal to momentum after collision. Momentum before collision. There are two particles in a system, so along x-axis. This is the X-ray radiation is coming along x direction, so the momentum is h by lambda. This electron is at rest, so its momentum before the collision is 0. After scattering, the momentum of the photon along x-axis is h by lambda dash cos theta, and the electron momentum is p cos phi. This is the equation number 1 and this is the equation number 2. Now momentum along y-axis. Now we will apply momentum along y-axis. Before collision, X-ray is not have any component along y direction, so it is a 0. Electron is also at rest, is it have no any component before the collision along y-axis, it is 0. But X-ray photon have the momentum along y-axis after collision. After collision, the component of the momentum along y-axis is h upon lambda dash sine theta, and in y direction it is a minus p sine phi. This is the equation number 3. So with the help of these three equations, we will solve Compton shift. H by hc by lambda plus hc by lambda dash plus m naught c square I'm writing equation number 1 again. Sc by lambda minus sc by lambda dash m naught c square is equal to hc by lambda dash plus p square c square plus m naught square c4. This is the equation number 1. Equation number 2 is h by lambda plus 0 is equal to h by lambda dash cos theta plus p cos phi. And the third equation was h by lambda dash sine theta minus P sine phi. These are the three equations. So with the help of first equation, what will we do? H by lambda dash, Hc by lambda minus Hc by lambda dash plus m naught c square is equal to p square c square plus m naught square c4. Taking square on both sides, Hc by lambda minus Hc by lambda dash plus m naught c square is equal to p square c square plus m naught square c4. By applying the a plus b whole square formula, we can open this bracket as hc by lambda minus hc by lambda dash whole square. This is the a plus b square m naught square c4 plus 2 hc by lambda minus hc by lambda dash m naught c square is equal to p square c square plus m naught square c4. M naught square c4 cancel out. It become sc by lambda minus sc by lambda dash whole square plus this and c square. So by dividing the whole left hand side by the c square, we get h by lambda minus h by lambda dash whole square plus 2hc m naught because c square cancel out and I am taking the common as hc. It is the 1 upon lambda minus 1 upon lambda dash is equal to p square. If this is the equation number 2, this is the equation number 3. And after solving equation number 1, it is equation number 4. Now from the equation 2 and 3, squaring equation 2 and 3 and adding. Squaring and adding. So first of all, equation number 2 can be written as Sc upon H upon lambda minus H upon lambda dash cos theta is equal to P cos phi. And the equation 3 can be written as H by lambda dash sin theta is equal to P sin phi. These are the equation number 2 and 3. So squaring and adding, we will get h by lambda minus h by lambda dash cos theta plus h by lambda dash sin theta is equal to p square cos square plus sin is cos square phi plus sin square phi is equal to 1. This is the equation number 5. So this is the p square from the conservation of momentum equations 2 and 3. And this is also p square from the equation number 1, which is due to the conservation of energy. Now, in what will we do? We will equate equation number 4 and equation number 5. Equation number 4 equal to equation number 5. This is the equation number 4. H by lambda minus h by lambda dash whole square plus 2hcm naught 2hcm naught 1 upon lambda minus 1 upon lambda dash. This is the equation number 4 is equal to equation number 5 h by lambda minus h by lambda dash cos theta whole square plus h by lambda dash sin theta whole square. Now we will solve it. H by a minus b whole square bracket h by lambda whole square plus h by lambda dash whole square minus 2h square lambda lambda dash, and it will be plus 2hc m naught, and it is a lambda lambda dash minus lambda is equal to h by lambda whole square plus h upon lambda dash whole square cos square theta plus h by lambda dash sin square theta. This is 1. It become, so by cancel out, first of all I will write all the terms. H by lambda square plus h by lambda dash whole square minus 2h square upon lambda lambda dash plus 2hc m naught lambda dash minus lambda upon lambda lambda dash is equal to h by lambda whole square plus h by lambda dash whole square. And here is a one more term is here, a square plus b square minus 2ab, 2h square lambda lambda dash cos theta. I will write these terms also, minus 2h square lambda lambda dash cos theta. So by cancel out these terms, it is a 2hc m naught lambda dash minus lambda upon lambda lambda dash is equal to 2h square upon lambda lambda dash minus 2h square upon lambda lambda dash cos theta. Taking common as a 2h square upon lambda lambda dash, it is a 1 minus cos theta, and it is a 2hc m naught lambda dash minus lambda upon lambda lambda dash. Cancel out these terms. 2 by 2, h by this h. And this lambda dash minus lambda, which is also called as a Compton shift, it comes h upon m naught c 1 minus cos theta. So Compton shift lambda dash minus lambda is equal to lambda is h upon m naught c 1 minus cos theta. Delta lambda is equal to h upon m naught c 1 minus cos theta. This is the expression for Compton shift. Theta is the angle of scattering of photon. Scattering of photon. Delta lambda, putting the value of h 6.6 into 10 to the power minus 34. Rest mass of the electron is 9.1 into 10 to the power minus 31. And c is 3 into 10 to the power 8. 1 minus cos theta. It becomes 0.0242 1 minus cos theta. Delta lambda is equal to 0.0242 1 minus cos theta, or delta lambda is equal to lambda dash minus lambda 0.0242 1 minus cos theta. If angle of scattering of photon is 90 degree, then Compton shift is called 1 Compton shift. The change in the wavelength will be 0.0242 angstrom. If theta is equal to 180 degree, then the change in the Compton wavelength is 0.0484 angstrom. This is the maximum change in the wavelength at when the angle of scattering is 180 degree. These are called the Compton shift expression. References of my lecture: Concept of Modern Physics by author Beiser, Solid State Physics by S.O. Pillai, and Engineering Physics by S.K. Gupta. Thank you for patience listening.